In this lecture, we're going to learn about some things you need to be careful about when overloading with const pointer and pointer to const parameters. Let's look at a simple example. Here we have a max function, and we have two overloads for it. The first one is going to be overloading based on int pointer. The second one is going to be overloading based on const int pointer. And because const int pointer and int pointer are two different types, these are going to be valid overloads in C++ code. So you can call these functions and they are going to work fine. Here we have a simple example of how we can call these two functions. Int a and int b are not const. So if we pass the addresses of them, we're going to call the non-const pointer version. And if we pass the const variables here and pass the addresses as we do here, we're going to call the overload that is using const int pointer. The problem is going to come if you try to overload and make the pointer itself const. Let's suppose we have these two overloads here. The function name is main here, and we take different parameters in these two functions here. The first one is going to take const int pointer, and the second one is going to take const int pointer const. So the pointer is going to be pointing to something const, but the pointer itself is going to be const. It can't be changed to point somewhere else. But what is going to happen, the compiler is going to look at these two functions and think they really are the same. And the reason is the pointer itself is going to be passed by value. Okay, I'm going to repeat this. The pointer is passed by value, and there is no point in making the pointer itself const. Because if we make the pointer point somewhere else, it's going to be a copy pointer. So when we try to modify it, we want to be modifying the pointer on the outside that we passed as an argument to this function here. And that's the reason why the compiler is going to really think these two functions are equivalent. And this situation is really a variant of what we saw in the last lecture, where we were passing different things by value, where one was const and the other wasn't const. It really is the same thing. The only difference is that we are applying that to a pointer now. Okay, if we try and set up these two definitions, we're going to have a redefinition compiler error, and we will have to fix this problem to get our program to run. Okay, this is really all I wanted you to be aware of in this lecture. Now we're going to head over to Visual Studio Code and play with these things a little more. Okay, here we are in our working folder. The current project is overloading with const pointer and pointer to const parameters, a really lengthy name. We're going to grab our template files and put them in place. And we're going to open this little guy in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. We're going to open our folder. Let's open our main CPP file and close this left pane. And we're going to clean it up a little bit. The first thing we're going to do is put in two overloads of the same function. We are overloading on the parameters we pass in here. The first one is going to take int pointer parameters. The second one is going to take const int parameters. Pointer to int and pointer to const int are two different things, so these are going to be valid overloads. And we can go down in the main function and set up a few variables to really play with these things. So we're going to set up four variables here, a, b, c, d. A and b are going to be non-const, c and d are going to be const. We are trying to really target any of these overloads in here. And we're going to say auto result equals max a and b. We're going to pass in the addresses of these two variables. We're going to say address of a. That's what we should say because we are taking by pointer. The parameters are being taken by pointer, and we're going to see which one gets called. We are passing in non-const variables, and we are passing the addresses of these variables. So we expect the one without const to be called here. Let's see what gets called. We're going to build, and we're going to build successfully, and we can clear. Let's bring up a terminal so that we can clear properly. We can clear and run rooster. Now we're going to see max with int pointer called. This is what we expect. Because we are passing the address of a variable which is not const by itself. So this is going to select the correct overload that we expect here. If we try and pass in the addresses of C and D, let's do that. we're going to be passing in addresses of variables which are const. So this is going to select this overload here. Let's build and prove that. We're going to use GCC. The build is good. We can clear and run rooster. We're going to see that max with const endpointer called, and this is going to select our overload here. And again, the message here is that these two guys are a valid overload. You can overload your functions based on whether the pointer is const and the pointer is not const. This is going to be valid C++ function overloads. The problem is going to come if you try and make the pointer here const itself. And to really drive the point home, we're going to go down and set up two other overloads for the main function here. One is going to be taking in a const endpointer. The other is going to be taking in a const endpointer const parameter. So for the second overload here, the pointer is going to be pointing to const data, but the pointer itself is also going to be const. And again, the compiler is going to look at these two functions and say they are the same. Let's first show the compiler error. We're going to build this with GCC, and we're going to get a compiler error. We're going to say redefinition of int main const endpointer and const endpointer. Why do we have this compiler error? The compiler thinks these two functions are equivalent, because in here we are trying and protect the pointer from modification. But the pointer is really passed by value. What we really have inside the body of this function here is a copy which is different from what we will have on the outside of the function. And the changes we do inside the body here are not going to affect any outside pointer. The pointer we have inside here is a copy, so it really is the same as the other overload we have here in the eyes of the compiler. In other words, the const we have after the star symbol here is really useless because this is a copy anyway, so we are not achieving anything from protecting this guy from modification because the changes we do in the body here are not going to be visible on the outside anyway. This is a copy we are working on. And some of you might be thinking this is really the case we handled in the last lecture, and it really is the same. The only difference is that we are applying that to pointers now, and that's what we're going to see here. Okay, so if we really want this to work, we will have to take out one of these guys. So we're going to take this out, which doesn't have a second const after the star symbol here. And we're going to try and run this and see the addresses of these pointers on the outside. Okay, so to really try this, we're going to comment out what we had before, and we're going to set up two variables. I think we can use C and D that we had here, so we can copy them and put them down here. And we're going to set up pointers to these guys. And we're going to say const int pointer, and we're going to say PC, meaning pointer to C, and we're going to initialize this guy with the address of C. We can do that. And we're going to say const int pointer, PD, pointer to D, and we're going to initialize this guy with the address of D here. Okay, now that we have this, we can call our function. The return type of this function is int, so we can grab that in the main function here. Let's say auto result, and we're going to say equals main, and we're going to be passing in our two pointers, PC and PD. If we do this and try to compile the program, it is going to compile. But what I want you to see is the addresses of the pointer variables themselves. PC is a pointer, PD is a pointer. It is a variable living somewhere in memory. This variable is going to contain the address of another variable, but this variable has an address in memory. It is a variable in our program, so it must have an address. And we can grab the address of PC and PD here and print them out. So let's do that. We're going to say stdc out address of PC, and we're going to print that out. We're going to say address of PC here, stdndl, and we're going to do the same for address of PD, and we're going to put this out. And once we call the function is going to be called here, and it is also going to print the addresses of the pointer variables that were passed in here as arguments. And we're going to see that these addresses are different. Okay, so if we pass PC here, it is going to take the place of A here. If we pass PD, it is going to take the place of B here. And we're going to see these guys printed out. Again, the goal is to see that the address in PC and A are different. The address in PD and B are going to be different. Let's build again and see if the build is even good. We're going to see that the build is good. We can clear and run rooster. We're going to see that the address in PC ends in DD8. Address A ends in DB0. The address in PD, DD0. And the address in B is DB0. So hopefully this is going to prove that our pointers are passed by value themselves, and the compiler really is reasonable in thinking that these two guys are the same. And you really need to be aware of this and don't set up overloads like this. Otherwise, you're going to get the compiler error that we have seen here, and this may throw off many beginners. That's why I went through the trouble to really explain this and give you as many examples as I can. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can overload with const references, and we're going to see some things to be careful about. Go ahead and finish up here and meet me there.